Alright, so we're on page 207. And we're going to start with applications of the distance formula. So in this lesson, we're actually going to derive and then use the formula for finding distance between 2 points in a plane. So if you will remember, the distance formula goes something like this, and it's given right here. So the distance equals the square root of x1 minus x2 quantity squared plus y1 minus y2 quantity squared. So that's the distance formula that we're actually going to be using. So number one, construct a right triangle on the axes to the right so that the distance between the 2 points is the hypotenuse of a triangle. So we know we're going to be connecting these 2 points. But it says connect them so that we make a right triangle. Well, a right triangle has to have what? A 90-degree angle. So we're going to go straight across here and then straight up and make that 90-degree angle. And this point here where this 90-degree angle would occur, what point would that be? What point would that be? Use your other points to help you figure out. Right? Yeah, 3, 2. Alright, so we've done number one. That was construct a triangle. So we're on to number 2. What is the measure of the vertical leg of the right triangle? Use the coordinates of the points given to find its length. So we're trying to find this right here. How long that leg is. Right? Okay, so we know it's going to be 4, but how do we mathematically find that, or how did you know it was 4? Yeah, we look at the y and the y, and what do we do with the 2y values? Subtract them. 6 minus 2 equals 4. So number 3 is, what's the measure of the horizontal leg of the right triangle? Use the coordinates of the points given to find its length. So now we're looking at this side. So we know it's going to be 5. Again, we're using the coordinates. What are we subtracting? 8 minus 3. That gives us 5. Very good. So number 4 says, use the Pythagorean theorem to find the distance between the points. Who remembers what the Pythagorean theorem is? Okay, a squared plus b squared equals c squared. I'm going to write it a little differently, but that is correct. We're going to write a leg. So one of the legs would be a. So leg squared plus leg squared equals, what's this called, the longest side? The hypotenuse squared. So a squared plus b squared equals c squared. Our first leg was what? Was 4 squared. The next leg was 5 squared. And then our hypotenuse, we're going to label that side over there d. So d squared. And why do you think I labeled that as d? What are we trying to find? Distance, yeah. We're trying to find the distance from that point to that point. We're using a triangle to help us. So now if I square these, I get 16 plus 25 equals d squared. 16 plus 25, I get 41 equals d squared. Then how do I get d by itself? Yep, take the square root, so I get the square root of 41. If we were to approximate that, anybody have a calculator, find the decimal? What is the square root of 41? .4. I have 6.403, so yeah, really close. So before we just go on to the next problem, does this answer make sense? What we're saying is D, the distance here, is 6.4. Does that make sense with this being 4, this being 5, that this side would be larger than those two? Yeah, our hypotenuse of the triangle should be the longest side. Very good. Alright, so we used the Pythagorean theorem there, but it actually is a form of the distance formula. So if you see up here, if you're x1 minus x2, if you just think about that as x or a, and your y's is b, a squared plus b squared equals c over here. Well, where'd the square go? Well, we took the square root of the other side. So the distance formula is really just the Pythagorean theorem, but solved for that c value. So let's go down to the bottom of the page. We're going to use that reasoning. So on the grid below, 2 points, x1, y1, and x2, y2 are plotted. Follow the directions to the left to derive the distance formula.
Please excuse the interruption. Everybody who's taken the keystones, please report to your assigned class. Even if you're not taking them and don't want to take them, you still have to report to your class. Thank you.
Alright, so number 1. Construct a right triangle on the axis to the right so that the distance between the 2 points is the hypotenuse of the triangle. So again, we're going to connect them so it's the longest side. And again, we're trying to find that distance there. This is a right angle, and we have this point again. So in terms of these 2 points here, what would this point be? So in terms of x1, y1, and x2, y2, what will this point be? Using the same notation. Think you have it, Marie? Not quite. We're not trying to find the distance yet. We're trying to find out what that point is. Go ahead. Yeah, it's going to be x1 because we're at the x1 on the x-axis. And at the height, we're at y2. So this point is x1 comma y2. Very good. Alright, now we're going to move on to what Marie was talking about. Number 2, what is the algebraic expression that can be written to represent the length of the vertical leg of the right triangle? Use the coordinates to find its length. So Marie, do you think you know what you're doing for this one? Yeah, y1 minus y2, exactly. For number 3, the algebraic expression for the length of the horizontal leg. Who thinks they can do that one? Go ahead.
I said x2 minus x1.
Exactly. x2 is the bigger one, so x2 minus x1. Alright, so now use the Pythagorean theorem to find the distance d between the points. The result should be the distance formula that was presented above. So, we have y minus y2, or y1 minus y2 squared, plus x2 minus x1 squared equals the distance squared. So a squared plus b squared equals c squared. And I'm going to flip these around just so we have solved for d. So how do I actually get d by itself? What am I doing to both sides? Square root. So I have, now this is addition, so I can do it either way. I can add this first. So I'm going to have x1 minus x2 squared plus y1 minus y2 squared. Now, why can I go from x2 minus x1 to x1 minus x2 here? Why does it not matter? Exactly. It's to the second power, so you're going to square it. When you square anything, you're going to get a positive. So I can switch the values. It's just going to give me a negative value, but when I square it, I'm going to get that positive value back. So to fit the formula we have from up above, d equals the square root of x1 minus x2 squared plus y1 minus y2 squared. Well, that's exactly what we got down here. So we used the Pythagorean theorem, that's what we started with, and you actually end up with the distance formula. Okay. Did we know that before? The distance formula from the Pythagorean theorem? So some people did, some people not. Alright, let's go into the back. For each of the following, determine what kind of triangle is formed by connecting the given points as the vertices of the triangle. Give a reason for your answer. So before we actually solve these and determine the triangle, what do you think they mean by kind of triangle? How are we going to answer those? What are some different kinds of triangles? Yeah, that's what we're going to be referring to. Whether something's isosceles, scalene, equilateral, that's what we want to think about when we get to our final answer. All right. So we learned the distance formula on the first page, so that's probably what we're going to be using. So let's take a look at it. It says determine the kind of triangle that is formed by connecting the given points. So we have 3 different points there. Well, a triangle has 3 points. So what we actually need to do is find the distance between what? The distance between what? We do A and C, A and B, or B and C. We need to find all 3. Okay? So we're going to start out with the distance between A and B. And we're given our x's and our y's, so we can just fill into the distance formula. So if we're dealing with A and B first, what are we subtracting? We have negative 2 minus 6. We're going to subtract the x values, square them. Then we're going to add, and we're going to subtract the y values. 5 minus negative 1, well that's 5 plus 1. And we're going to square that. And leave us with square root. Negative 2 minus 6, negative 8. Negative 8 squared is what? We get 64 plus 6 squared is 36. So that's square root of 100. Square root of 100 is what? 10. So the distance from A to B is 10. So that's our first. And if you want to visually think about it, if you draw a triangle, it's not drawn to scale, but if you have A, B, and C, we're finding the distance from A to B, then B to C, and then C to A. That's what we're trying to find. We're trying to find all 3 distances. Alright, so BC is next. Again, we're using that distance formula. So based off of what we did for the first one, who can tell me what we're going to be subtracting here first? Go ahead, Marie.
6 minus 5 and 6 plus 1.
6 minus 5 squared. And then what? Sorry?
6 plus 1. Wait, sorry. Yeah,
Keep it in the same order. So for this one, you had the 6 first, so the y value from B should come first.
25. Well, a negative 1 minus 6.
Yeah. So if you pick the B x value first, you should use the b's y value first. That's just, you should go in that order. Just like when you're finding slope, you always choose the first point first and stick with it with your x and y value. Okay. So 6 minus 5 is 1. So we would get square root of 1 squared is just going to be 1. Negative 1 minus 6, you get negative 7. Negative 7 squared is negative 7 squared? 49. So we get square root of 50. Now I could see where this could break down to something a little more simpler. Anybody else see it? Square root of 50 could be broken down. Yeah. What is the square root of 25? 5. So we're going to have 5 square roots of 2. That's our second answer. Okay. And lastly, we're going to find from C to A. So starting with C, we'll have 5 minus negative 2, so that's 5 plus 2 squared, plus 6 minus 5 squared. Well, 5 plus 2 is 7, and we already said before, 7 times 7, 7 squared was 49. Square root of 49. 6 minus 5 is 1. 1 squared is 1. So we're going to get square root of 50. Square root of 50 reduces to what again? Five square root of 2. Yeah, 5 square root of 2. So we have found our 3 side lengths. We found this one, then we found B to C, and then we found C to A. We found all 3 of them. So now, after finding the 3 lengths, what can we say about this kind of triangle? It's isosceles. So try to find an area. I'll write it right here for now. Triangle ABC is isosceles because there are 2 congruent sides. Triangle ABC is isosceles because there are 2 congruent sides. So are we okay with this example? Thumbs up, we're okay to go on. Thumbs down, we need some more time. We're alright? Not sure? Good? Alright, so we're going to go on to the next one. Is anybody still copying this down? I'm going to erase it just so I know I have enough room. Alright, so the second one. We're going to start with AB again. We're doing the same process, but we have new points. So we have 2 minus negative 1, so 2 plus 1, plus negative 3 minus negative 7, so that's plus 7 squared. So we get square root of 9 plus 16. Which is the same thing as square root of 25, which simplifies to what? Somebody I haven't talked to today. Square root of 25 simplifies to what?
5.
Yes, thank you, 5.
Please excuse the interruption. I need the following students to report to their assigned area. That is Carter Halloran, Ashton Gway, Logan Morgenstock, Sam Lynn, Dylan Sands, Isaac Spencer, Vince Vogel, Eli Lindsay, Xavier Barnes, Jack Mason, Cheyenne McGough, Joel Wilson, Jake Watinsky, Eric Bodley, Tyler Bodley, Lillian Vogan, Matt Grove, Anna Greco, Isabel Painter, Abby Patch, and Sebastian Salazar. Please report to your Keystone area. Thank you.
Alright, so the next side, I've already started setting it up. We're going to find the distance for BC. So -1 minus 6 squared, -7 minus 3 squared, and take the square root of all of that. So -1 minus 6, well, -7 squared, so again that's 49. -7 minus 3, -10 squared, that's 100. So square root of 149. And we're just going to leave that answer like that for now until we get our next one to see if we need to reduce it. So square root of 149. And lastly, we'll go to CA. Square root. So we're going to have 6 from there, minus 2 squared, plus 3 minus -3, so that's 3 plus 3 squared. 6 minus 2 is 4. 4 squared is 16. And then we get 6 squared is 36. So we get the square root of 52. So we have our 3 side lengths. So now that we have our 3 side lengths, what can we say about this triangle ABC? Go ahead, Marie.
ABC is scaling because they're related to each side.
Triangle ABC is scalene. None of them are the same because there are no congruent sides. So what do you think of the distance formula so far? Pretty easy? As long as you keep your points straight, you plug into the formula. And I think if you can remember that the formula is based off the Pythagorean theorem, I think that even makes the distance formula a little easier to remember. Alright, so that's it for the second one there. So now if we go down to here, it says, what does it mean for point A to be equidistant from points B and C?
It is usually distance from both points, meaning it will not be scaling, but it could be isosceles or collateral.
Okay, so it's going to be the same distance, so what we're saying is side AB is going to be equal to side AC, because we know 2 of them are going to be the same. So thinking of that as a picture, we would have point A, and we would have some point B and some point C. And the distance from A to B and A to C would be the same. So we mark that with the hash marks. So from A to B is the same as A to C. They're equidistant. So we're going to use that reasoning in the next few problems. Is the point P, 4, 2, equidistant from point A, 9, 2, and point B, 1, 6? Show your work. So we're going to use the distance formula again and find the distance between both of them to determine if it is the same distance. So first we will find from P to A, because we want to know if A and B are the same distance from P. So we're going to go from P to A. So square root. And if we're starting with p, we have 4 minus 9 squared. And then we have 2 minus 2 squared. So 2 minus 2 squared, we know that's going to be 0 squared, so that goes away. What's 4 minus 9? 4 minus 9. If we get negative 5, you square it, and that becomes 25. So we get square root of 25. Well, the square root of 25 is just 5. So that's our side from P to A. Now we're going to go P to B. So 4 minus 1 squared plus 2 minus 6 squared. Well, 4 minus 1 is 3. 3 squared is 9. 2 minus 6, we get negative 4. Well, negative 4 squared is positive 16. That gives us square root of 25 again. And square root of 25 also simplifies to 5. So now answer the question. We've shown our work. It said show your work. Answer the question. Is the point from P to A and P to B, is it equidistant? Yes. So that's all we need to say. Yes, it is. Does it make sense how we found that? Going too fast? Too slow? All right. Okay. So we get 5 and 5 for both side lengths. So let's go ahead and try the next one right beside it. All right. Is the point Q, 1, 4, equidistant from A, negative 5, negative 3, and B, negative 1, negative 5? Show your work. So from Q to A and Q to B. So we're going to start with QA. So Q's x value is 1. 1 minus negative 5, that becomes plus 5. Then we'll do our y values. So 4 minus negative 3, so that becomes 4 plus 3. Six squared is 36. 7 squared is 49. Square root of 85. And we'll just leave it there. So we know this side is square root of 85. Now let's figure out what it is from Q to B. Again, Q is 1, so we have 1 minus a negative 1, so plus 1. Plus 4. 4 minus negative 5 becomes 4 plus 5. Square that. 2 squared is 4. 9 squared is what? 9 times 9? 81. So we get square root of 85. So are those 2 points equidistant from Q? Yes, they are. Alright, so not too bad. We used the distance formula twice. If the numbers come out to be the same, that is showing that our distance from A to C, in this point it was Q to A, and Q to B, are the same. Alright, so our next two problems are going to be similar. The same type of idea, but there's a little bit more to it because we are missing a value. We don't know this value here for K. Alright. So we're still going to be using the distance formula. It talks about being equidistant. So let's read the problem. If the point 2, k is equidistant from both 9, 2 and 1, 6, find the possible values of k. So if they're equidistant, what do we know about the distance from both of those? We've stated this already, but what do we know about their distances? If they're both equidistant, they're both what? The same, or equal to each other. So what we need to actually do is find the distance using the distance formula. So on the first side, we're going to start with our point that we're equidistant from, so this 2 minus k. So if you want to label them, this is kind of like A, B, and C, and you could kind of refer to your picture from up above if you want to label those. So if we would start with A, we would have 2 from our x value, minus, and we're going to the B right now, so 2 minus 9 squared, plus, well, our y value, we don't know that, that's k. K minus 2 squared. So the distance between those 2 points is this, and that's going to be equal to the distance between these 2 points. So again, we're going from this point A to C now, so 2 minus 1. And then k minus 6. And that's the setup. Distance formula on both sides. We know the distances are going to be equal to each other. So the distance over here is from A to B. The distance over here is from A to C. We just don't know what these k values are yet. So now let's try to simplify a little bit. Well, if we have a square root equal to a square root, what can we do with those square roots? Yeah, so if we go to get rid of one on one side and we square it, we're going to square the other side, so the square roots are going to what? Go away, they're going to cancel. So these are going to go away, so we would be left with, well, let's simplify the underneath a little bit. We know the square roots are going to go away. So 2 minus 9, we get negative 7. Negative 7 squared is 49. We still have k minus 2 squared. Over here, square root's gone too, because we said if we square both sides, they're going to disappear. 2 minus 1, well, 1 squared is 1, plus, and we still have k minus 6 squared. Well, now let's actually expand this. So we're going to have 49. What is k minus 2 squared? What are we actually going to get? So actually break that down. Do k minus 2 times k minus 2. What do we get? K squared. We will have a plus 4, but we're going to have a term in the middle. What's our middle term? Anybody help her out? Minus 4k. Okay, very good. So that's on the left side. On the other side, k minus 6. So square that. What are we going to get on that side? So do the same thing we just did on the left, but this time for k minus 6. Yeah, go ahead. K squared minus what? Sorry. Not plus 12. Yeah, plus 36. There we go. So now if we simplify, if we move a k squared over, well, those are going to cancel. We'll subtract them off, so they're going to disappear. So on this side, we have 49 plus 4, so we have 53 minus 4k equals, on the other side, we'll get 37 minus 12k. Yeah. If I take k squared and I subtract it over to the other side, what's k squared minus k squared? So that's just, I was simplifying it ahead of time. It's just going to make this process easier. So now what I'm going for is combining like terms. I'm trying to find what k is. So if I move all my k's to the left and all my numbers to the right, I'm going to solve for it. So I'm going to add 12k, because I'm subtracting here. So negative 4 plus 12. Well, negative 4 plus 12 is 8k. And I'm going to subtract 53. Well, if I have 37 and I subtract 53, I will get negative 16. What can I do lastly? Yes, Marie. Divide by 8 and you get k is equal to what?
2.
Close. Close.
Negative 2.
Negative 2. There you go. So we used the distance formula, knowing that these 2 points were equidistant, and we found what the k value of our original point is. So our original point would be 2 comma negative 2. Because k is equal to negative 2. Alright, so using the same reasoning, the same format, the same reducing, go ahead and try the last problem on this page. We have like 5 minutes or so left, so go ahead and try it. If you want to check with your partner, go ahead and check with your partner or work with your partner. And at the end, we'll check to make sure you have the right answer. But take some time and solve this one. So it's going to be the same setup. Alright, so I know some of you are still working, some of you are finishing up. I want to go ahead and put the answer up here just so you can check your answer. So what should our k value be? K should be equal to what? K should be equal to 8. So if you didn't get that, you should go back through your work and check. You should get k equals 8. The last step you get before you solve that, you should get negative 4k equals negative 32. And when you divide that, your negatives cancel out, so you should get k is equal to 8. Okay? So go back through, make sure that you multiplied everything correctly, make sure you squared everything correctly, but it should simplify to k equals 8.